Welcome to Chapter 4. This chapter is mostly about triangles. Today we're going to learn how to classify triangles by their sides and angles. We're learning the triangle sum theorem and something called the exterior angle theorem. First, let's classify our triangles. If you have a triangle with all different side lengths, and sometimes you'll see that marked as tick, double tick, triple tick, just to show that all of those side lengths are different. There's a special name for a triangle like that. It starts with an S. It's called a scalene triangle. If you have a triangle that has two sides that are congruent, you might have heard of this one before. It starts with an I, isosceles triangle. And if all three sides are congruent to each other, do you know what that one's called? It starts with an E, equilateral triangle. There's also names for triangles that are dependent upon their angles. So if you have a triangle that has three acute angles, we call that an acute triangle. A triangle just has to have one right angle to be called a right triangle. A triangle just has to have one obtuse angle to be called an obtuse triangle. And a special type of acute triangle that has three congruent angles, all the angles are congruent to each other, is called an equiangular triangle. Equiangular. Here's a triangle on a coordinate plane, and we are going to try to classify this by its sides and by its angles. So in order to classify by its sides, we need to find the lengths of the sides. And to find the lengths of the sides, we will be using the distance formula. So I might start by just labeling those vertices, A, B, and C on that triangle. So I'm going to need to find three lengths on this triangle. First, I'll find the length from A to B. And we do that by taking x minus x and y minus y. In the distance formula, that order doesn't matter. And we're going to take negative 5 minus 2, which is negative 7. Negative 7 squared is positive 49. 6 minus 3 is 3. 3 squared is 9. And so this comes out to the square root of 58, which is about 7.6. Next, let's find the length of BC. Again, we'll take our x minus our x and our y minus our y. And this time I get a positive 3 squared and a positive 7 squared. And that matches the length of my first one. Finally, the length of that third side, AC. X minus x and y minus y. That comes out to negative 4 squared, which is positive 16, and 10 squared, which is 100. The square root of 116 is about 10.8. So we are now ready to classify this triangle by its side lengths. We have two congruent sides. What do you call a triangle with two congruent sides? Isosceles. We don't have all the tools to classify a triangle on a coordinate plane by its angles, but what we can do is we can check some slopes on those lines, because remember, we can tell if we have a right triangle by checking our slopes. We can tell if our lines are perpendicular. And when you look at this triangle, I'm wondering, do you think angle B up here might be a right angle? It looks like there's a chance. So I'm going to use the slope formula And let's find the slopes of those two lines that look like they could be perpendicular. To find the slope of AB, I could either do my y minus y over x minus x, or since it's already graphed on here, I could count my rise over run. And this one goes down 3 over 7. So when I find the slope of BC, what would I be looking for? If I wanted perpendicular, I'd be looking for a positive 7 over 3, right? In order for those to be perpendicular, let's find out. Again, if I were using the formula, I would go y minus y over x minus x, or another way I could do this is taking a rise over run. So let's see, up 1, 2, 3, 4, 5, 6, 7 over 1, 2, 3. So up 7 over 3, up 7, right 3, and that's exactly what we were looking for, wasn't it? That tells me that those lines, AB and BC, are perpendicular. And if those are perpendicular, what kind of angle do they form? A right angle. So we can classify this triangle as an isosceles right triangle. I know that was a lot of work. I only assigned 2 of those problems. It is a good idea to get some practice with those distance formulas. That's a huge thing coming up in math. And it's always good to work on our slope too. Our first theorem of the chapter is called the triangle sum theorem. It has to do with the 3 angles in a triangle. Do you know what those angles add up to? The triangle sum theorem tells us that those 3 angles add up to 180 degrees. Here's a little demonstration that goes with the triangle sum theorem. Here I've got an obtuse scalene triangle. It's got the 3 angles labeled in here, and we're just gonna manipulate that a little bit. So angle 1, angle 2, angle 3. And the triangle sum theorem says that if I take angle 3 and, oh, what is she doing? Oh, it's a massacre. What has she done? Okay, she's torn off angle 3. She wouldn't. She's doing it. She took angle 2. All right, so she's gonna take the 3 angles, and the triangle sum theorem says that those 3 angles are supposed to make 180. So how can we demonstrate that? Now we could prove this. It's totally a theorem. The theorem says that you can prove it. This is more of just a demonstration. So she is showing that we could add those 3 angles. Oh, do you see that? Those 3 angles are forming a straight line altogether, aren't they? So if those 3 angles form a straight line, when you line them all up, those 3 angles add up to 180. And that was just some random triangle. So those 3 angles adding up to 180. It's a nice demonstration of the triangle sum theorem. Not a proof. We could prove it since it's a theorem, but just a cool demonstration. And we can do some sweet algebra using the triangle sum theorem. I have a triangle, I have the 3 angles labeled, and I always know that the 3 angles, the sum of those measures, will always equal 180. I'll be combining my like terms here. Subtracting 55 from both sides. And finally dividing by 5. And x equals 25. You know what I like you to do once you find x, right? Where do I plug it back in? Into the equation or into the picture? In geometry, we plug it back into the picture to make sure it makes sense. So I plug in a 25 here and I get 50 degrees. And I plug in a 25 here and I get 75 degrees. By the way, what kind of triangle is that? We'd have to classify it by its angles, since I have its 3 angles. What kind of angles are those? Acute angles, so that's an acute triangle. The exterior angle theorem, this is a new one. first of all, an exterior angle is if we extended one of these sides out. The exterior angle is this one right here that is marked as angle 1. And there's actually a relationship between the measure of that angle and some of the angles inside the triangle. The exterior angle theorem tells us that the measure of that exterior angle is equal to the sum of the measures of the two non-adjacent interior angles. Let's talk about which angle is adjacent to that one. Adjacent means right next to this. So this one is adjacent to angle 1. So which angles are not adjacent? That would be angles A and B right here. So the exterior angles theorem says that angle 1 is equal to the measures of angle A and B added together, which I think makes sense because if I ripped off all three of the angles, we know that those would make one big straight line. So if we ripped off these two, they should line up right over in angle 1 over here, right? Let's see if we can use that in an equation. So in this picture over here, which one is the exterior angle? Well, they've got this side of the triangle extended, so the exterior angle is the 3x minus 22. So that exterior angle, according to the exterior angle theorem, is equal to the two non-adjacent interior angles added together. The 80 plus the x would have to equal that exterior angle. That's what the theorem says. Now my x's are on opposite sides, so maybe I could subtract x from both sides. Add 22 to both sides. And divide by 2. If I plug that back into the picture, that makes this one a 51-degree angle, which seems believable. And then 3 times 51 minus 22 is 131. And that does make sense because then the 80 plus the 51 equals that exterior angle. And the last theorem of the day is called the corollary to the triangle sum theorem. A corollary is just another theorem that goes along with it. The triangle sum theorem, again, was that one where the three angles add up to 180. The corollary is just a special case where you're talking about a right triangle. So what happens if you already have one of your angles that's a 90? What do the other two angles have to add up to? If all three add up to 180 and you've already used up 90, how much is left for angles A and B? Well, 180 minus 90 leaves another 90 degrees for A and B to share. So we say that those two acute angles on this picture, angles A and B, are complementary. They have 90 degrees together to share. Angle A plus angle B has to equal 90. And that's just sometimes kind of a nice shortcut for finding a missing angle. If you know it's a right triangle and one of your acute angles is a 20-degree angle, instead of going with the whole 180, we can just know, oh, okay, well, these two angles have to add up to 90. So what plus 20 would add up to 90? That would be a 70-degree angle up in there. So that might just help make some of your calculations a little quicker. All right, there are a few problems on your homework where you're going to have to use some knowledge that you have from before and do some problem solving. You'll notice that this picture has some parallel lines, so you're going to be able to use some of that stuff that we used last chapter. Let's try to find angle 1 first. We'll just go in order. Angle 1 should be congruent to which other angle if those are parallel lines? Maybe I'll try to highlight so we can see this a little better. If these are parallel lines, we could use this as the transversal. Can you see that this would be an alternate interior angle then? So that means that angle 1 would be 50 degrees. Should we try angle 2 next? Angle 2. Can we use the parallels again? We've got parallel lines. Where could we make our transversal? Probably using this line as our transversal, since that makes our angle 2. Where would our angle be? Could we use the 70 then? Do you see how the 70 and angle 2 would be alternate interiors? So the 70 degree would match up with the angle 2. One thing that I think is going to be helpful this chapter, do you see that alternate interior angles always make sort of a Z shape? Do you see that? So I'll refer to that a few times this chapter about how if you can make a Z shape with those angles, you've found yourself some alternate interior angles. So angle 2 is 70 degrees. Let's find angle 3 next. Angle 3, I'm seeing a couple ways we could do angle 3. Did you notice that angle 3 is part of a triangle? And now that we have our triangle sum theorem, we could use that. We've got the 70, we've got the 50, and we've got the angle 3. We know those have to add up to 180 degrees. These two make 120. So how much more would we need to make 180? Is that 60 degrees? So that would be a 60 degree angle. Another way we could check that then is to make sure that these three angles add up to 180, because do you see that straight line? Are those adding up to 180? We've got 50 plus 60 is 110 plus 70 is 180. That's a good sign too. Finally, let's try for angle 4 out here. I think we could use our parallel lines again, but just for funsies, do you see how angle 4 is actually an exterior angle to this triangle? Remember the old exterior angle theorem that we just learned? That exterior angle is going to equal the two interior angles added together. That would be a nice easy way to find the measure of that exterior angle. So 80 plus 50 is 130, and that would give us angle 4 right away. The exterior angle theorem. So we have lots of good problem solving tools now for finding lots of missing angles.